All right, here is an example of factoring quadratics by grouping. So this is factoring quadratics where a is greater than 1. So we know that we're going to be dealing with binomials that have coefficients to x. So it won't be x plus or minus something times x plus or minus something. We're going to have numbers in front of the x. In order to do that, factoring by grouping is a really good strategy. Kind of the same format as we were when we had a equaling 1, except we have to add in one more step to account for the a. So we need two numbers that multiply together to be a times c. So kind of similar to when a was 1, except it'd be 1 times c, so multiplies together would be c, but add together to be b. So first we need to identify, well, what is a times c? Well, a is 15 and c is -4. So 15 times -4 is -60. And then it needs to add together to be b, which is -4. So I just start listing off the factors that multiply together to be -60. So I'm thinking, what about 10 times -6? 10 times -6 is -60, but 10 plus -6 is +4. So it didn't work, but it was close. What if I just switch the negatives? So if I had -10 times 6, again, that would multiply together to be -60. And when we add them together, it's going to be -4. So perfect. So now these are the two numbers that I'm going to need to use. However, they're not the two numbers in my binomials. They're actually the two numbers that I need to break apart this middle term into. So I still have my 15x squared, and then breaking up -4x into those two numbers, I get -10x plus 6x minus 4. Now, I could have put the 6 first and the -10 second. That part doesn't matter. It would just change how I pull the greatest common factor out of both halves. So now I need to pull the greatest common factor out of the first half of my polynomial and the second half of my polynomial. So breaking this polynomial into two halves. So looking at the greatest common factor between 15x squared and -10x, well, the greatest common factor of 15 and 10 is going to be 5. And then they each have an x term, so I can pull out an x term from both of them. So pulling out the greatest common factor of 5x from the first half, well, 5x times what is 15x squared? Well, that would be 3x. And then 5x times what would give us -10x? Well, that'd be -2. And then doing the same thing with the second half, pulling out the greatest common factor. I'm going to want the binomial from both of these to be the same. So I want to keep this minus in minus. That way it's still a subtraction in my polynomial or my binomial. So factoring out the greatest common factor between 6x and 4, well, that's going to be 2. So 2 times what is 6x? Well, that'd be 3x, which is the same as this one. So that's perfect. We're right on track. And then 2 times what is -4? Well, that'd be -2. Perfect. And that worked because I need this binomial to match this binomial. That way I can factor the binomials out, like reverse distributive property. So I have 3x minus 2 times what's left, which is the 5x plus 2. So these two binomials multiply together to be 15x squared minus 4x plus minus 4. And I could do that with just remultiplying together. So typing that in, that would have been 5x. Oops, I'm just going to type it on my actual keyboard. So flipping that back over. So we get 5x plus 2. Oops, I didn't need those in parentheses. And then 3x minus 2. And let's see if we're correct. And we are. So we can add a sticker. Voila. We were good on that. Let me know if you need another example. I will definitely email you some more examples if you need it.